reorganizing of the data. So I'm going to take, for example, oops, do that again. I'm going to take the data and I'm just going to make it into one column. So these columns are unnecessary, and I can delete that and just call that demand. And I think I'll be able to grab these two, oops, these two together, yeah, and pull them down like that. I think I'll add a column back here, insert for year. Put that over there, bolderize it. So I think we started 2012. So I want that number to come down to here, and then I want to add 1 to that, and if all goes well, oops, all didn't go well, so that's fine. I'm just going to make this 2013. So much for being fancy. Grab that and then go down here and make this 2014. And then come down to January and make this 2015. Okay, and I don't know, just for sake of consistency here, to turn off the bold there. Okay, so now that's the demand, and notice that when we saw this in the module that the demand follows an annual pattern. So the number of periods in a cycle is 12. So this would constitute, each year would constitute one cycle. So the first step is to deseasonalize, and just so that I can have columns of fairly narrow lengths here, I'm going to write down deseason, and keep in mind that you should be looking at this after you've looked at all of the module notes, because there are two formulas that are useful for the deseasonalization depending on whether you have an even or odd number of periods in a cycle. So I'm going to use the term month instead of period here because it applies to this problem, and a cycle is 1 year. So we have 12 months in a cycle. So we want to start this with the 1, 2, 3, 4, 5, 6, 7th, and you'll see why we want to do that in a few seconds. And you might want to say, you could think about this starting point as a little bit of trial and error if you want, but here's the formula. It's equal to, I don't need to set a left parenthesis up, it's equal to the demand in January plus 2 times the demand in February plus 2 times the demand in March. Now I would have to just keep doing this all the way down through the whole year, and that's very tedious. So I'm going to backspace. I'm going to write 2 times the sum of the February data through the December data. Then I'm going to plus the January number. I'm going to end my parenthesis, and I'm going to divide that number by 24. Now, I would like to make sure that you understand intuitively what we're doing here. Notice that while everything's highlighted here in our formula, you notice that I'm looking at the kind of the red middle section here that gets multiplied by 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 of the periods that get twice the weight in this calculation, and then we have the 2 Januaries that get kind of a weight of 1 each. So they combine. So January combines for a weight of 2, which is equal to the weight of these other months. So actually this is a really good way to see what this formula is doing. In fact, you can see physically that this formula is in the middle of these values here. If you look before this row, we have 1, 2, 3, 4, 5, 6, and after this row we have 1, 2, 3, 4, 5, 6. So this deseasonalization formula is centered on these values, and it's the weighted average of those. And I am going to just make a few less decimals. And by the way, keep in mind that when you do something in a classroom, you might say manually, like I did with the module, versus doing it in something like Excel here, there's a lot of rounding off that happens in the module that won't be happening here. I mean, we're going to show that there's 111.0, but the actual number is actually 110.98, and that will affect final results. And so you're going to see that the final results in this demonstration are a little bit different, but just by a small amount than the final results in the lecture. All right, so now I'm going to take this formula and I want to copy this down so that it's kind of symmetric with the endpoint. And I'm just going to do something here that you might end up doing just as a mistake. Let's say you copy it all the way down, but then you realize, no, wait a minute, it doesn't go all the way down because these numbers are supposed to be the middle of a bunch of numbers here. But if you put your cursor, for example, on the last one and just click up here, you notice that that's clearly not a correct calculation. If we put it way up, let's say in April, you notice that that's okay. I'll escape and I'm going to go down to June. You notice that's the last one we want to do. So I'm going to escape and I'm going to start with July, and I'm just going to delete these. Alright, so there's my deseasonalized demand. Now the next step in this is to create a regression line with these values, and the regression line has to have an index associated with it. So one of the things I'm going to have to do, and I could have done this at the beginning, is I have to go back here and insert an index, because that will actually be very important in terms of, oops, I don't want dates here, so let me make that a number. And if I double click, I think that will just go all the way down to 48. Okay, I'm going to need that in my regression, and I'm going to also need it for the forecast itself. So as you know from the previous demonstration, if you don't already know it, we can go to data analysis, regression, and our Y range is the deseasonalized demand. Our X range is the index that goes along with that I just created. And notice, very important, that, oops, let me do that again, something went wrong. Notice, very important, that the deseasonalized numbers are these numbers, and they don't encompass all of the indices. So I want to make sure I get the indices that are consistent with that. I do not have labels, so I do not want to check that. And for the output range, I'd like to leave it in this spreadsheet. I just need to put it off to the right somewhere so it's not in the way. I'll just say, I don't know, L9. Doesn't really matter where it goes. In fact, let me move it up a little bit. I'll make it L2. Okay, there we go. And I'm just going to reformat a little bit here so that we're consistent with what you saw in the notes. And remember, the key thing here are these coefficients. The coefficients are 97.43 and 2.11. And notice they're also in cells. And see the cell up here? It's 97.4321922616.595, so that when I'm actually using those cells in the calculation, we can actually use the real number here and not the rounded off number. And again, that will lead to some small differences in our final results when you see the final forecast. So that's the deseasonalized demand. Next thing we want to do is we want to use the regression to create a value down here in column F that are the values we call D bar in the note. So let's just call this D bar. And in words, what we're dealing with here is this is what the model would provide with just the level and trend components. So what we want to do is we want to say this is equal to the coefficient here, and of course we want to use a dollar sign to freeze the row 18, plus the coefficient. Again, we'll put a dollar sign in there, times the index. So notice that we are actually applying this model, this D-bar model, through the regression on the right side. I'm going to apply this to all the indices, all the months, not just the months that we've deseasonalized. So again, I'm going to bring this all the way down. So this is the forecast without the seasonal component. The next step is to find the S bar values, and as we say in the module, these are simply the adjustments for the season. So what we do is we take that, we make this equal to the demand divided by the forecast that does not include the seasonalization. So the first one is 0.15, and copy down. You see how when you know what you're doing, it's really easy. Okay, so we go to S bar, and again, S bar is the demand divided by the D bar. So the demand divided by the model without the seasonalization factor. Then, because we have 4 cycles or 4 years here, we want to come up with the seasonal factor. So I'll just call this the seasonal factor, which is, we call it S in the model. So the value of S for January will be the average of the four Januaries. The value for February will be the average of the 4 Februaries. So we can take the average of January's value, the January value, the January value, and the January value. That's 0.52, and that'll work well for the first 12 of these. So for example, you can confirm by going to the last one, just kind of clicking on it and seeing that we have the December, the December, the December, and the last value of the December. All right, but we do need to use these values to create forecasts down here, because we're going to have to find forecast errors and things. So obviously we can't just bring this down, because if we did that, we would have January, we would miss the first one, and we would actually end up below the range of the data here. But we can escape that, and what we could do is we could say that's equal to the first one. So if we do this and we copy this down, you'll see that these values are repeated here. See the December value is 2.0. And by the way, if you're ever doing something in Excel like this, it's good to check your results, obviously, but one convenient way to check calculations is always just look at the first one and the last one. Sometimes you could look at one in the middle, but the first one and the last one usually are going to tell you if you got this right. So if we look at January 0.52 and December 2.0, and we go down here, here's the 2.0 for December and the 0.52 for January right there. You notice that it looks right. So now we want to come up with a forecast. So the forecast is equal to the forecast without the level and trend components, times the forecast with the seasonal factor adjustment. Do that. First one's that value, and we copy that down. So now we have forecasts for each period, and we have the demand for each period. And one of the things I'm not going to, but yeah, all right, I will. Just going to highlight this column and this column, because from this point on, these are our most important columns. On the next video, I'll show how to create margin of uncertainty, but for now we see that we can create a forecasting model, and we can then use this model to forecast, let's say, January. So that would be 2016 January, which is the 49th month. We simply take this value. First of all, we bring this down, and we take this value and we just copy it, notice that it's that number times that number, and so the forecast for January is 104.0. In the note, it was shown as 104.